In this video, I'm going over those extra 10 practice problems that we created, just in case if you needed that extra practice as we're preparing for your fall final exam. In the first three questions, we are using this function f of x here to answer these three. So question one is about the domain, question two is about the range, and question three, we have to figure out which of these statements describe the function. So really in the end, what I need to know is how this graph even looks, right? Like looking at question number three, I need to know what the end behavior is. Where is it increasing or decreasing the function? So what I'm going to do is in this case, make sure to use Desmos. Now, before we take a look at Desmos, remember your domain and range. So the domain is always the x values, and the range is always the y values. So here, for example, for the domain and range, we're saying it's all reals except for which of the values. So remember that the graph, our rational function, like this one, for example, does not exist at the whole and at the asymptotes. So that is where the graph does not exist. And remember, the asymptotes could be our vertical asymptote, which is our x is equal to a value, and it could also not exist at the horizontal asymptote, where y is equal to a value, if there is one. So keep in mind that these are the two where the graph does not exist. So we're basically in question one and two, we're identifying, is there a whole? Because then we need the x and the y value. Well, remember the whole is the common factor. So looking at this function here, is there a common factor that we could cancel out? Well, no. So is there a whole in this function? No. So we're just going to focus on identifying the asymptote, the vertical asymptote, and the horizontal asymptote. So what is the domain? Now let's look at the graph here. And remember that the vertical asymptote is your up and down, right? Crossing the x-axis. So I'm looking here to see at what value is our x. So notice how we're getting closer and closer in the x values, but we're never reaching -2. Notice again here how the graph is approaching, but never reaching -2. So it's getting closer and closer to that x value, but never reaching -2. So that is the vertical asymptote, which means that's why the answer is B, all reals except for -2, because the vertical asymptote was at x was equal to -2. Also notice in the denominator, what can x not equal to make this this fraction, this rational expression, undefined? It cannot equal -2 because we can't have 0 in the denominator. So now question number two, what is the range? So now we're looking for the horizontal asymptote. What is y equal to? So again, I'm going to go back to the graph and notice here the y value. So what is the horizontal where the graph is approaching but never reaching? Notice how we're getting closer and closer to our y value of 3, but never reaching that y value of 3. And again, notice here how it's again approaching, but never reaching that y value of 3. So that is our horizontal asymptote. So because the horizontal asymptote is y is equal to 3, then that is our range. It's all reals except for that y value of 3. So now question number three, which statement describes the function? So we're looking basically, if you think about it, right, our true statement. So as x approaches positive infinity. So let's go back. What is our graph approaching? So as we're going to the right towards positive infinity, well, what direction is our graph going? Well, notice how the end is not, it's going down, yeah, but it's not going all the way down to negative infinity. It's approaching 3. So as we're going to the right towards positive, it's getting closer and closer to, but never reaching 3. So A is not our answer because it's not approaching infinity. Our f of x is approaching 3. So the function is increasing over the interval. So let's look back at our graph. Well, I notice here, first off, read it left to right. Is our graph going up or is it going down? We're going down. It's decreasing. Here, read the graph left to right. What direction are we going? We're going down. We are decreasing. So that means it cannot be B because there is no interval of increase. There's only decrease. As x approaches negative infinity now. So as we're going to the left, f of x is approaching 3. So here, let's look back at our graph. As we're going to the left, right, towards our negative infinity, notice how the end is approaching that y value of 3. We're going up, right, but not all the way up to positive infinity. We are approaching 3. So the answer is C. So for those who thought it was D, this says that the function is decreasing. So we said there's only intervals of decrease, but over the interval of -5 to 5. So remember, that's the x values we're looking at from -5 to 5. So I'm going to look back at my graph from -5, which is here, to 5, which is here. But is our graph constantly decreasing over that interval? Well, no, because it's split, right? We have this vertical asymptote at -2. So the graph technically is not continuing on because it's stopping at -2 and then continuing on from -2 on. So that's why the answer is not B, and it's C. Question number 4. Which statement describes the function? So again, here we have the domain is, now there is no hole. The domain is all reals except for 1. Well, remember the domain is your x values, which means I need to know what is my vertical asymptote because there is no hole. Well, notice here it's getting closer and closer, but never reaching x is equal to 4. So the answer is not A, that is false. Range is all reals except for 0. So now remember the range is your y values. So we're here they're saying that the all reals are except for 0. So y is equal to the horizontal asymptote. Well, notice how our graph is approaching but never reaching this y value, which is here at 1. So the answer is not B. As x approaches positive infinity, so as we're going to the right. So that here, as we're approaching infinity, is our f of x approaching negative? Well, it's going down, our graph, but is it going down all the way down to negative infinity? No, because remember, it's flattening out here, right? It's approaching but never reaching 1. So here, it's approaching 1, so it's not C. So let's check to make sure that our answer is B. The function is decreasing over the interval from 4 to infinity. So starting at 4, so again, that was our vertical asymptote. So 4 on to infinity. So as we're going here, what direction is our graph going? Read it left to right. We are going down, the values are decreasing. So that's why the answer was D. So question number 5. You're having to, again, look to see which statement is but incorrect, right? Make sure to read. So which statement is false about this function? So again, here you're given the equation. Now this is a polynomial, not a rational, but we need to see the visual of the graph to identify which of these statements is true. So make sure to graph the function in Desmos. Here's how the graph looks in Desmos, so make sure that once you practiced it or you graphed it that you have the same as me. And which statement is false? So as x approaches infinity, so as we're going towards our positive infinity, this says f of x is approaching negative infinity. Now remember, we're looking for false. So as we're going to the right, what is our end approaching? So as we're going to the right, so as we're going here, what direction is our graph going? Down to negative infinity. So this statement is true. So here we're looking for false. Over the interval, -1 to 0. So that's our x values. the values of f of x are positive and decreasing. So over the interval, -1 to 0. So as we're looking here from -1 to 0, so we're looking at this section of our graph. We'll notice that these values are above the x-axis. So notice how our y values are all positive, and reading it left to right, we're going down, decreasing. This says positive and decreasing as well, which makes this also true. So B is not our answer. The degree of the function is 4. So remember, degree is like our exponent. So when I'm going to go back to my equation and add up my exponents. Well, this is 2 plus 2. Now keep in mind, we do have x here, which has an exponent of 1, adding up to 5. So let's double check and make sure that this statement is false looking at our graph. Notice how here we do have our 3 zeros. We have a slice at 0, which is the exponent of 1. Then we have the bounce, which is 2, and there's our bounce again, which is 2. So 2 plus 1, making that degree of 5. Also notice how the ends are going opposite directions, which makes this an odd function, not an even function. So that's another reason why I can tell that this is not 4, but it has to be odd, making it 5. Let's just check to make sure that D is also true. As x approaches negative infinity, as we're going to the left, what is our end or f of x approaching? So as we're going to the left, the graph is going up to positive infinity, which is true. So now in question number 6, here's another review on our polynomial functions, but we are dividing these two polynomials. Now notice, because we're dividing by 3x plus 3, we cannot use synthetic because of this coefficient of 3 here, so we do have to do long division. So we're going to set it up. We're dividing 3x plus 3 into our polynomial expression here. Do we need a 0? No, no term is missing. Remember to always check to see with division when we were dividing by our polynomials if we need 0 as a placeholder. Now remember, we're always dividing the first term into the first term. So 3 goes into 3 one time. So I'll still put the 1 there as kind of like a placeholder. And then we're only taking out 1x. We started off with 3 x's, so now x squared. Then we would multiply. 1 times 3, that's always going to match up to 3x cubed. But don't forget to multiply 1 to the plus 3. So 1 times 3 is 3 and x squared. Then before we combine, change the signs because you're subtracting, distributing a negative. So now that's 0 canceling out, and combine like terms, you get negative 30 x squared. And always bring down the next term. Now again, we're dividing the first term into the new first term. So we're now going to divide again the 3, but what's our new first term? Negative 30. So 3 now into negative 30, or negative 30 divided by 3. Negative 10, and then 1 less x. So now when you multiply, right, that's going to match up. So there's your negative 30x squared, but don't forget to multiply the negative 10 again to the what? Plus 3 here. So negative 10 plus 3, negative 30x. Then again, what do? Change the signs because you're subtracting, you're distributing a negative. So this is 0 canceling out. Combining like terms here, you now have 3x. Then bring down that last term, plus 4. And again, divide the first term into the new first term. First term again 3, but into the new first term, which is 3. 3 divided by 3 is 1. And 1 less x, so it's just plus 1. Then multiply. So when you multiply, that will always match up, right? So there's your 3x. But again, don't forget to multiply the 1 to the positive 3 here. So 1 times 3 is 3. And then again, make sure to change the signs because you're subtracting, you're distributing a negative. So that's 0, and 4 minus 3 is 1. So remember, this 1 is your remainder, positive 1. So our final answer when you divide is x squared minus 10x plus 1 with your remainder, so plus 1 over 3x plus 3. Question number 7. Which statement is true about this rational function here? So we're now looking to see all these different parts. So I'm going to go through and start factoring. Now you could also graph this in Desmos, but remember Desmos doesn't show if there's a hole. So I'm going to go ahead and start factoring. Now I notice in my numerator that I have a GCF of not just 2, they also have, every term has at least 1x. So I have 2x as my GCF. So in my numerator, I have a GCF of 2x. Then now I've got x squared plus 7x plus 12, just 12. Because here 2 divided by 2 is 1, 14 divided by 2 is 7, and 24 divided by 2 is 12. Now I still have the trinomial here, so let's check to see if we can still factor. Are there two factors that multiply to get 12 and add to get 7? Yes, 4 and 3. So really the numerator with our GCF of 2x is x plus 4 times x plus 3 times that GCF of 2x. Then in the denominator, we again have a GCF. Notice how they both have at least one x. So I can take out the GCF of x, factor that out. So now I've got x here, then times, well, taking one x out, now you're just left with 1x, then minus 6. There's nothing else I can do, so that is my denominator. So now let's look back. Do we have a common factor? Because remember, the whole is taking out a common factor. Do we have a common factor? Yes, we do have a common factor. What do both the numerator and denominator have that can be canceled out? We have an x here. And remember, when identifying our characteristics, that this is all equal to 0. So if I have a common factor of x, that means that we do have a whole at x is equal to 0. So A is false. Now I'm going to look back and again cancel out, so this would be eliminated. Then we always got the zeros from the numerator and vertical asymptote from the denominator. Again, all equal to 0. So that means the vertical asymptote here in my denominator. Well, if this is x minus 6, then that means my vertical asymptote is x is equal to positive 6. But this says negative 6. So B is false. Remember, we're looking for our true statement. Then the zeros. Again, all equal to 0. So this is x is equal to, our x values should be equal to, for our zeros, so here, let me actually write out the coordinates, should be -4, 0 and -3, 0. Because again, we have our factored form setting equal to 0. But this stayed at +3, +4. So the answer is not B. So the answer is C. This is our true statement. Because, go back to the original. So I'm going to go back and erase this so we can see the original. With the horizontal asymptote, we always look at the degree, the exponent. Notice how we have a degree of 3 in the numerator, but a degree of 2 in the denominator. 3 is greater than 2. So because now we have a greater than, this meant there was no horizontal asymptote. So now let's see if you could check this with the graph. What if you're unsure, right? So what are the zeros of the graph? Well, notice here, our graph is crossing at -4 and -3. So notice the calculations do match. That is the 2. Now this is not a 0. It looks like it because see how it's just above it? So those are the 2 zeros. So that's how we could tell that the calculations match. We also said that the vertical asymptote was at +6, not -6. So again, I could look back at the graph. Now, I notice here though, see how this just shows this one piece. So how are we supposed to tell? Well, guys, again, practice and notice how practice if you need to zooming out. And notice here is that other function like our rational. Notice how the graph is approaching but never reaching an x value of +6. Again, notice how our graph is approaching, but it's never reaching, and we could keep going, but at x is equal to +6, not -6, which is over here. So that's why this also works out and matches. Then you can also tell that there is no horizontal asymptote. There is no what is y value that the graphs are approaching but never reaching. So that's why, again, you can visually see that the answer is C. Question number 8, which statement is true about the function? So the domain, the x values, is all reals except for this one value of -2. So again, remember, the graph does not exist. We use our whole and asymptote. So in this case, we would look for the vertical asymptote. X is equal to a value. So now notice how we do have our vertical asymptote right here at -2, but we do have a whole at the x value of 2 as well. So A is false because it's both -2 and 2, where the graph, the domain, does not exist. So B, the graph is increasing. Well, first off, look at the graph. Read it left to right. What direction are we going? Down, decreasing. Look here. What direction are we going? We're going down. We're decreasing, not increasing. So B is not an answer. So now let's look at C. As the x's are approaching -2. So as our graph, the x values are actually approaching the x value of -2 here. So we're actually looking now at this portion of our graph because we're approaching the x value of -2. Well, what direction is our end? What are we approaching? Well, the graph is going down to -infinity. This says +infinity. So this statement is false. So let's check to see that our answer is D, that this statement is true. The graph is decreasing, so far so good, over the interval from starting at the x value of -2 and going on to infinity. So starting here at -2, what direction? We are decreasing. So yes, D is our true statement. Question number 9. This is review on solving for x. So remember, when solving the equation, make sure to identify what are the values that are extraneous. So x cannot equal, according to our denominators, -4 and +6. So keep in mind that those are the two values that are extraneous. Now we do have just like two proportions here. Our two denominators have nothing in common, nothing can be factored. So now we just cross multiply. So 5 times x minus 6 is equal to cross multiply x times x plus 4. So now here I'm going to distribute, and I've got 5x minus 30 is now equal to, again, distribute, x squared plus 4x. Now notice we are solving a quadratic. So our quadratics always have to equal 0. So I need to subtract 5x. I also need to add 30. So this means I've got x squared minus 1x or minus x plus 30. Now we can factor. What multiplies to get 30 and adds to get -1? -6 and +5, which means when we're solving here, that x is equal to 6 and -5. Guys, be careful because then people are going to want to say B. B is not our answer because always go back to the extraneous. Notice how 6 is one of our extraneous solutions. X cannot equal 6, so X is only equal to -5. That's why the answer is C. And question number 10. This is review again on our polynomial. So the local neighborhood is building a new rectangular playground. So I've got a rectangular playground here. The width of the playground is represented by the function 3x squared minus 5x minus 1. And the length is represented by this function here, x squared plus 6. But after they started the project, they decided to change the width. So we're going to change the width here, which was our 3x squared function, so that it is 4x units more than and 2 units less than the original width. So we're going to change the width so that it is, so I'm going to go ahead and rewrite my original width, which was 3x squared minus 5x minus 1, so that it is now 4x units more than. So we're going to add 4 more x's and 2 units less than, which is subtraction. So I'm going to subtract 2 units. Notice how combined like terms from the original width, which means now the new width is still 3x squared, but now minus 1x or minus x minus 3. I'm going to go ahead now and replace this width with the new one that they changed, which is now 3x squared minus x minus 3. Now let's read our question. How much fencing will they need to enclose the playground? So we're looking for what is the fencing to enclose this area. So I'm not talking about the entire inside. We're talking about the outside, which is perimeter. And how do we find perimeter? We add up all 4 sides. Don't just add up these 2, right? We need to add up the 2 lengths here. So I have double my 2 lengths. And then we have, remember, our new width. So 3x squared minus x minus 3. So we're adding to that, we're doubling our new width here, 3x squared minus x minus 3. Now, you don't have to double like how I showed here. You could just now go through and start adding, combining like terms, and you'll get the same answer. So here I've got 2x squared plus 12 from distributing 2 here, we're doubling, plus 6x squared minus 2x minus 6. Again, we're doubling. Then combine like terms. I've got 2x squared plus 6x squared, which is now 8x squared. I only have my one x term here, so minus 2x, but we do have 12 minus 6, which is 6. And this is the polynomial that represents our perimeter.